Recursion is an abstract concept for most new programmers, but it's very simple. It is a function that calls itself inside of its own body. One function calls the next, which calls the next, and in theory, you want it to eventually stop. Think of it as a way to loop through a problem without using a for or while loop. Recursion is all about breaking problems down into its simplest step. A lot of people use the idea of divide and conquer. You divide the problem down and build it back up using the solutions of the parts. Suppose here is the start of our problem, or the initial function call. In a recursive function, it will call itself on a smaller part of the problem and continue to do so until you reach the smallest possible solution to the problem, which we call the base case. The base case is what allows the program to terminate eventually. Once you reach the base case, the function calls make their way back up, returning the solution from the previous part so that the next function call can use it in its answer. The goal with each recursive call is to get our problem closer and closer to the base case. That's because recursive functions must have a base case or they will never end. See, I believe solving factorials is a really simple way to visualize the problem-solving mindset you need for recursion. Note, solving factorials is very easy to do iteratively using loops. However, its recursive solution is elegant in my opinion. Let's look at what a factorial is. Factorials are the product of all the positive integers less than or equal to the given start integer. 5 factorial is simply just 5 times 4 times 3 times 2 times 1. But look here in our definition of 5 factorial. We can find a 4 factorial embedded inside of it. 4 times 3 times 2 times 1. Well, that means that we can write 5 factorial as 5 times 4 factorial. But then we notice a 3 factorial, so we can write 4 factorial as 4 times 3 factorial, and eventually we see another 2 factorial and 1 factorial if we keep breaking it down. We can keep using this idea to break down the factorials until we get to the most basic definitions of factorials. 1 factorial is simply 1 because there is nothing else to multiply by. And mathematicians have come to the consensus that 0 factorial is 1 also. So, if you notice, these are the definitions for the most basic forms of our problem. These are our base cases. Here's the recursive solution for the factorial problem. We have a public function which returns an int called factorial, which takes in an integer we call n. Notice this conditional. We say if n equals 1, next is the OR operator, so if n equals 1 or n equals 0, return 1. If you notice, this is our base case. The else is implied because if the condition cleared, then the function would return before the rest of the code is complete. But else we are going to return n times the factorial of n minus 1. This is the same thing that we said in the last slide. This is our recursive call. Notice how we are calling the same factorial function we are in, except this time we call it with intentions to get closer to our base case by decreasing what's passed into it by 1. Let's see really quick what happens when we do factorial of 3. Factorial of 3 returns 3 times factorial of 2, which then returns 2 times factorial of 1, which from our base case returns 1. Our code then works its way back up using the definitions from the smaller problems to answer the bigger problem. So then factorial of 2 is evaluated to 2 times 1, which of course is 2. And then factorial of 3 is evaluated to 3 times 2, which is of course 6. And then we have our answer. That being said, our solution still isn't perfect. It does have some bugs in it. Let's suppose what happens when somebody tries our factorial function on a negative number. This, of course, we know cannot happen because factorials of negative numbers are impossible. But the computer doesn't know this. It only knows what we told it. Factorial of negative 2 then returns negative 2 times factorial of negative 3, which then returns negative 3 times factorial of negative 4, and so on and so forth, until we eventually get the dreaded stack overflow error, which essentially tells the computer it entered an infinite loop. So how do we improve our solution? It is quite simple. Notice this is practically the exact same function as before, but this time we have two base cases. The first one now checks for any negative values. If it is negative number, it returns -1, which is a common error message since Factorial shouldn't even return a negative solution in the first place. But you might ask, why should you learn recursion when you can just use loops to do the same thing? Certain problems will become way easier to solve, more intuitive, and more efficient with the use of recursion. It simply depends on the specific problem you are solving. It often makes your code more readable and easier to understand, and you can solve any problem with loops using recursion. And that's all you need to know to understand the very basics of recursion. If you enjoyed it, feel free to like and subscribe. Thank you for watching.